Permutation, combinations and binomial theorem. Concepts of permutations and combinations. Let 1, 2 and 3 are 3 digits. Taking 2 digits at a time, we can write 12, 21, 13, 31, 23 and 32. These are called permutations. Therefore, taking two from 3 different things, we get 6 permutations. Number of arrangements that can be made taking some or all from some things are called permutations. If we take 3 digits at a time, we will also get 6 permutations such as 123, 321, 231, 213, 312 and 132. In general, number of permutations of n different things taking r at a time is expressed as npr. Therefore, in our above example, 3p2 is equal to 6 and 3p3 is equal to 6. On the other hand, number of groups that can be formed taking some at a time from some different things are called combinations. For example, among 3 students, Mamun, Habib and Najmul, taking 2 at a time, we can form 3 groups such as Mamun and Habib, Mamun and Najmul, and Habib and Najmul. These are called combinations. Thus, from 3 different students taking 2 at a time, we get 3 combinations. If we take 3 students at a time, we get 1 combination Mamun, Habib and Najmul. In general, number of combinations of n different things taking r at a time is expressed as NCR. Therefore, in our above example, 3c2 is equal to 3 and 3c3 is equal to 1. Concept of factorial. N factorial or n factorial is called factorial n. Similarly, 4 factorial is called factorial 4, 3 factorial is called factorial 3, etc. 4 factorial is equal to 4 into 3 into 2 into 1 is equal to 24. 3 factorial is equal to 3 into 2 into 1 is equal to 6. N factorial is equal to n into n minus 1, n minus 2 into n minus 3 into n minus 4, that is 3.2.1. 11.2 permutations of things all different. Suppose you have 5 different digits such as 3, 4, 5, 6, 7. You would like to know how many permutations can be formed from these 5 digits taking 2 at a time. According to formula, 5p2 is equal to 5 into 4 is equal to 20. If you take 2 digits at a time, you will get 5p3 is equal to 5 into 4 into 3 is equal to 60 permutations. If you take 4 digits at a time, you will get 5p4 is equal to 5 into 4 into 3 into 2 is equal to 120 permutations. In general, number of permutations of n different things taking r at a time is npr is equal to n into n minus 1 into n minus 2 into n minus 3 into n minus 4 dash 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 n minus r plus 1. এটা হচ্ছে 1 number equation. Corollary 1, if r is equal to n, from equation 1 we get number of permutations of n different things taking all at a time. Npn is equal to n into n minus 1 into n minus 2 into n minus 3 into n minus 4 dash 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 3 to 1, 3 into 2 into 1 is equal to n factorial. Similarly, 4p4 is equal to 4 factorial is equal to 4 into 3 into 2 into 1 is equal to 24, and 5p5 is equal to 5 factorial. 5 into 4 into 3 into 2 into 1 is equal to 120. Corollary 2, from 1, npr is equal to n into n minus 1, n minus 2 into n minus 3 dash 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 into n minus r plus 1. Multiplying and dividing both sides by bracket n minus r bracket close factorial, we get npr is equal to n into n minus 1, n minus 2, n minus 3 dash dash to n minus r plus 1 into n minus r factorial divided by n minus r factorial is equal to n factorial divided by bracket n minus r bracket close factorial. This is very important and useful formula of determining number of permutations of n different things taking r at a time. Therefore 5p2 is equal to 5 factorial divided by 5 minus 2 factorial is equal to 5 factorial divided by 3 factorial. Then we get 5 into 4 into 3 into 2 into 1 divided by 3 into 2 into 1. Here we can cut 3 into 2 into 1 from denominator. Five into 4 is equal to 20. Then we get 5 into 4 is equal to 20. 6p4 is equal to 6 factorial divided by 6 minus 4 factorial is equal to 6 factorial divided by 2 factorial. লবে আমরা পাই হচ্ছে 6 into 5 into 4 into 3 into 2 into 1 আর হরে পাই হচ্ছে 2 into 1. 2 into 1 কাটা যেয়ে থাকে 6 into 5 into 4 into 3 into 1 is equal to 360. According to formula 2, if r is equal to n, npn is equal to n factorial divided by n minus n factorial is equal to n factorial divided by 0 factorial is equal to n factorial. Therefore 0 factorial is equal to 1. If r is equal to 0, np0 is equal to n factorial divided by n minus 0 factorial is equal to n factorial divided by n factorial is equal to 1. Permutation of things not all different. So far we have discussed about number of permutation of n different things, but if n things are not all different, p number of things are alike, q number of things are alike, s number things are alike, and the rest are different to each other. Then number of permutations of n things taking all at a time will be equal to n factorial divided by p factorial q factorial into s factorial. How many permutations can be formed taking all alphabets of the word commerce? The word commerce has 8 alphabets, of which m is twice, c is twice, e is twice, and the rest are one time. According to formula, required number of permutations is 8 factorial divided by 2 factorial into 2 factorial into 2 factorial is equal to 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1 divided by 2 into 2 into 2 is equal to 5040. Example 2. How many ways the alphabets of the word Chattogram can be formed? The word Chattogram has 10 alphabets, of which both A and T occur twice and the rest are different. Therefore, the required number of permutations is 10 factorial divided by 2 factorial into 2 factorial is equal to 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1 divided by 2 into 2. Then we get 9,07,200. Example 3. In how many ways the alphabets of the word Pubali can be arranged so that the vowels are consecutive and the vowels are not consecutive? Number 1. The vowels are consecutive means all vowels are like a single word. In that case, total alphabet of a given word will be 4, and these 4 alphabets can be arranged in 4p4 is equal to 4 factorial is equal to 24 ways. Again, the 3 vowels can be arranged among themselves in 3p3 is equal to 3 factorial is equal to 6 ways. Therefore, the alphabets of the word Pubali can be arranged in 24 into 6 is equal to 144 ways, keeping the vowels consecutive. 2. If no precondition is imposed, the alphabets of the given word can be arranged in 6p6 is equal to 6 factorial is equal to 720 ways, of which the vowels will remain consecutive in 144 as above. Therefore, the vowels will not be consecutive in 720 minus 144 is equal to 576 cases. Example 4. In how many ways the alphabets of the word mathematics can be arranged? In how many cases the vowels will be consecutive? There are 11 alphabets in the given word, of which M is twice, A is twice, T is twice, and the rest are different. So the alphabets can be arranged 11 factorial divided by 2 factorial into 2 factorial into 2 factorial is equal to 49,89,600 ways. The word mathematics has 4 vowels, of which A is twice. If all the vowels are considered as a single alphabet, there will be 8 alphabets, and in that case total permutations will be 8 factorial divided by 2 factorial into 2 factorial is equal to 10,080. The vowels can be arranged among themselves in 4 factorial divided by 2 factorial is equal to 12 ways. Therefore, the vowels will be consecutive in 10,080 into 12 is equal to 1,20,960 cases. Example 5. How many permutations can be formed with the word Haryana? In how many cases, of which of these H and L will be consecutive? How many permutations will start with capital H and end with capital N? The word Haryana has 7 letters, of which A occurs thrice and others are different. So total number of permutations will be 7 factorial divided by 3 factorial is equal to 840. B. If H and N are considered as a single letter, total letter will be 6, of which A occurs thrice. In that case, total number of permutations will be 6 factorial divided by 3 factorial is equal to 120. Again, capital H and N can be written 2 factorial is equal to 2 ways. Therefore, H and N will be consecutive in 120 into 2 is equal to 240 cases. C. Assuming H and N fixed, if we delete them, total number of permutations will be 5 factorial divided by 3 factorial is equal to 20. So 20 permutations will start with capital H and end with capital N. Example 6. A man has 7 flags, of which 3 are green and 4 are red. How many different types of signals can be made if he uses number A, all 7 flags at a time, B, exactly 4 flags at a time? A. Solution A. If he uses all the 7 flags at a time, number of signals will be 7 factorial divided by 3 factorial into 4 factorial is equal to 35. B. He can select 4 flags in following ways: green 3 plus red 1. Number of permutations 4 factorial divided by 3 factorial is equal to 4. Green 2 plus red 2. Number of permutations 4 factorial divided by 4 2 factorial into 2 factorial is equal to 6. Green flag 1 and red flag 3. The number of permutations 4 factorial divided by 3 factorial is equal to 4. Green flag 0 and red flag 4. 4p4 is equal to 1. Total is equal to 15. Therefore, using exactly 4 flags, he can make 15 signals. Example 7. How many numbers can be formed taking 1, 2, 3, 4 and 5 all at a time that are divisible by 5? Here are 5 digits. If all 5 digits are taken at a time, total number of permutations will be 5 factorial is equal to 120. The permutations with last digit 5 will be divisible by 5. So keeping last digit 5 as separate, the rest 4 digits will be written as 4 factorial is equal to 24 ways. Therefore, 24 permutations will be divisible by 5. Combinations of things all different. Suppose there are 5 members in a committee. We would like to know how many combinations, groups or subcommittees can be formed taking 3 members at a time. According to formula of combination, total combination or group or subcommittee will be 5C3 is equal to 10. If we take 4 members at a time, total combination or group or subcommittee will be 5C4 is equal to 5. If in general, number of combinations of n different things taking r at a time, r is smaller than or equal to n, is NCR is equal to n into n minus 1, n minus 2 into n minus 3, dash 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 n minus r plus 1 divided by r factorial. Multiplying and dividing right hand side by n minus r factorial, we get NCR is equal to n into n minus 1, n minus 2 into n minus 3, dash 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 n minus r plus 1 into n minus r factorial divided by r factorial into n minus r factorial, or NCR is equal to n factorial divided by r factorial into n minus r factorial. এটা হচ্ছে 4 number equation. This is the general formula to find out combination of anything. According to this formula, 5C3 is equal to 5 factorial divided by 3 factorial into 5 minus 3 factorial is equal to 5 factorial divided by 3 factorial into 2 factorial is equal to 10. Similarly, NC7 is equal to 10 factorial divided by 7 factorial into 10 minus 7 factorial is equal to 10 factorial into 10 factorial divided by 7 factorial into 3 factorial is equal to 240. If r is equal to n in formula 4, we get NCn is equal to n factorial divided by n factorial into n minus n factorial is equal to 1, since 0 factorial is equal to 1. A general rule of combination is NCR is equal to NCn minus r. 10C7 is equal to 10C3 and 8C2 is equal to 8C6. Prove that NCR is equal to NCn minus r. এটা হচ্ছে example 8. According to formula 4, NCn minus r is equal to n factorial divided by n minus r factorial into n minus n plus r factorial is equal to n factorial divided by হচ্ছে n minus r factorial into r factorial is equal to NCR. Example 9, prove that NCR plus NCR minus 1 is equal to n plus 1 CR. Left hand side is equal to NCR plus NCR minus 1 is equal to n factorial divided by r factorial into n minus r factorial plus n factorial divided by r minus 1 factorial into n minus r plus 1 factorial is equal to n factorial divided by r into r minus 1 factorial into n minus r factorial plus n factorial divided by r minus 1 factorial n minus r plus 1 into n minus r factorial is equal to n factorial divided by r minus 1 factorial into n minus r factorial, third bracket close, 1 divided by r plus 1 divided by n minus r plus 1 bracket close is equal to n factorial divided by r minus 1 factorial into n minus r factorial, third bracket n plus 1 divided by r into n minus r plus 1 third bracket close is equal to n plus 1 factorial divided by r factorial into n minus r plus 1 factorial is equal to n plus 1 CR is equal to right hand side. Prove that 12C4 plus 12C3 is equal to 13C4. 12C4 is equal to 12 factorial divided by 4 factorial into 12 minus 4 factorial is equal to 12 factorial divided by 4 factorial into 8 factorial is equal to 495. 12C3 is equal to 12 factorial divided by 3 factorial into 12 minus 3 factorial is equal to 12 factorial divided by 3 factorial into 9 factorial is equal to 220. 13c4 is equal to 13 factorial divided by 4 factorial into 13 minus 4 factorial. 13 factorial divided by 4 factorial into 9 factorial is equal to 715. 12c4 plus 12c3 is equal to 495 plus 220 is equal to 715 is equal to 13c4 proved. Example 11. From 7 boy students and 2 girl students, a committee of 5 should be formed so that A. 2 girls must be in the committee. B. No girl will be in the committee. In how many ways are this possible? Since 2 girls must be included, other 3 boys among 7 must be selected, and it is possible by 7c3 is equal to 35 ways. B. Since no girl will be in the committee, 7 boys should be selected out of 5, and it is possible by 7c5 is equal to 21 ways. Example 12. Out of 5 boys and 3 girls, a committee of 3 boys and 2 girls should be formed. In how many ways it is possible if A. No other restriction is imposed. B. 2 special boys must be included in the committee. Group of 3 out of 5 boys can be formed in 5c3 is equal to 10 ways. Again, group of 2 out 3 girls can be formed in 3c2 is equal to 3 ways. Therefore, A. If no other restriction is imposed, 10 into 3 is equal to 30 groups can be formed. B. As 2 special boys must be included, 1 boy out of the rest 3 boys should be selected, which is possible in 3c1 is equal to 3 ways. Therefore, in this case, it is possible to form group of boys and girls in 3 into 3 is equal to 9 ways. Example 13. Out of 7 business students and 4 science students, committee of 6 students should be formed. In how many ways the committees can be formed? If A. Exactly 3 business students must be in the committees. B. At least 3 business students must be in the committee. If exactly 3 business students are taken, the other 3 students should be taken from science students. From 7 business students, 3 business students can be selected in 7c3 is equal to 35 ways, and from 4 students, 3 science students can be selected in 4c3 is equal to 4 ways. Therefore, total committee can be formed 35 into 4 is equal to 140 ways. B. If at least 3 business students are kept in the committee of 6 may be formed in the following possible ways. Number 1. 3 business and 3 science students, 7c3 into 4c3 is equal to 140 ways. 2. 4 business and 2 science students, 7c4 into 4c2 is equal to 210 ways. B. If at least 3 business students are kept in the committee of 6 may be formed in the following possible ways. Roman 1. 3 business and 3 science students, 7c3 into 4c3 is equal to 140 ways. Roman 2. 4 business and 2 science students, 7c4 into 4c2 is equal to 210 ways. Roman 3. 5 business and 1 science student, 7c5 into 4c1 is equal to 84 ways. Roman 4. 6 business and 0 science students, 7c6 and 4c0 is equal to 7 ways. Therefore, committees can be formed in 140 plus 210 plus 84 plus 7 is equal to 441 ways. Example 14. A committee of 6 bankers should be formed among 10 bankers, of which 6 are from private banks and 4 from public banks. In how many ways the selection is possible so that private banks have majority than public banks in the committee? Solution: if private banks have majority, the members can be selected in the following ways. Roman 1, 6 from private and 0 from public. 6C6 into 4C0 is equal to 720 ways. Roman 2, 5 from private and 1 from public. 6C5 into 4C1 is equal to 24 ways. Roman 3, 4 from private and 2 from public. 6C4 into 4C2 is equal to 90 ways. So committee can be formed in 720 plus 24 plus 90 is equal to 834 ways. Example 15. In how many ways committee of 7 members from 10 boys and 8 girls can be formed so that every committee has at least 4 boys? If at least 4 boys are in the committee, it is possible to form committees in the following ways. 1. Roman 1, 4 boys and 3 girls. 10C4 into 8C3 is equal to 11,760 ways. Roman 2, 5 boys and 2 girls. 10C5 into 8C2, 7,056 ways. Roman 3, 6 boys and 1 girl. 10C6 into 8C1 is equal to 1,680 ways. Roman 4, 7 boys and 0 girls. 10C7 into 8C0 is equal to 120 ways. Therefore, committee can be formed in 11,760 plus 7,056 plus 1,680 plus 120 is equal to 20,616 ways. Example 16. A committee of 6 students is to be formed from 8 boys and 2 girls. In how many ways the committee can be formed so that Roman 1, 2 girls must be included in the committee, and Roman 2, no girl is included in the committee. Roman 1, since 2 girls must be included, 4 boys can be selected from 8 boys, and it is possible in 10C4 is equal to 70 ways. Roman 2, since no girl is included, 6 boys are to be chosen from 8 boys, and it is possible in 8C6 is equal to 28 ways. Binomial theorem: you know x plus y whole square is equal to x square plus 2xy plus y square. X minus y whole square is equal to x square minus 2xy plus y square. A plus b whole cube is equal to a cube plus 3a square b plus 3ab square plus b cube, etc. In each case, there are 2 variables such as x and y, a and b. The expansion where there are 2 terms like this is called binomial theorem. Similarly, a plus b whole to the power n is also a binomial theorem. Expansion of these will depend on the value of index n. We assume that value of n is positive integer. Binomial theorem for positive integer index: you know a plus b whole square is equal to a square plus 2ab plus b square. A plus b whole cube is equal to a cube plus 3a square b plus 3ab square plus b cube, etc. Note that if power or index is 2, number of terms is 3, and if power or index is 3, number of terms is 4. Similarly, if a plus b whole to the power n, total number of terms will be n plus 1. Now we would like to expand x plus y whole to the power n, where n is a positive integer. According to formula of binomial theorem, x plus y whole to the power n is equal to x to the power n plus nc1 x to the power n minus 1 into y plus nc2 x to the power n minus 2 into y square plus nc3 x to the power n minus 3 y cube plus dash 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 plus ncr x to the power n minus r y to the power r plus dash 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 y to the power n. Note that as index is n, number of terms is n plus 1. Also note that there is a very systematic consistency and relation among the terms of the expansion. Similarly, x minus y whole to the power n is equal to x to the power n minus nc1 x to the power n minus 1 into y plus nc2 x to the power n minus 2 into y square minus nc3 x to the power n minus 3 into y cube plus minus 1 whole to the power r dot ncr x to the power n minus r into y to the power r plus dash dash y to the power n. Note that number of terms of x plus y whole to the power n and x minus y whole to the power n are equal in number, but in case of x minus y whole to the power n, the terms are positive and negatively alternatively, and if n is even, the last term will be positive, and if n is odd, the last term will be negative. Expand, example 17. Expand 3x plus 4 whole to the power 4. Solution 3x plus 4 whole to the power 4 is equal to 3x whole to the power 4 plus 4c1 3x whole to the power cube into 4 plus 4c2 into 3x whole to the power square dot 4 square plus 4c3 into 3x into 4 cube plus 4 to the power 4 is equal to 81 x to the power 4 plus 4 to 32 x cube plus 864 x square 768 x plus 256. As n is equal to 4, number of terms is 4 plus 1 is equal to 5. Similarly, 3x minus 4 whole to the power 4 is equal to 81 x to the power 4 minus 432 x cube plus 864 x square minus 768 x plus 256. Example 18. Expand 2x minus y whole to the power 5. Solution 2x minus y whole to the power 5 is equal to 2x whole to the power 5 minus 5c1 into 2x whole to the power 4 into y plus 5c2 into 2x whole cube y square minus 5c3 2x whole square into y cube plus 5c4 2x into y to the power 4 minus y to the power 5 is equal to 32 x to the power 5 minus 80 x to the power 4 into y plus 80 x cube y square minus 40 x square x cube plus 10 x to the power 4 minus y to the power 5. General term plays a vital role in binomial theorem. The r plus 1th term of an expansion is called general term. In expansion of 2x plus y whole to the power n, the general term is ncr into 2x whole to the power n minus r in dot y to the power r, and in expansion of 3x minus 2 whole to the power n, the general term is minus 1 whole to the power r dot ncr into 3x whole to the power n minus r dot 2 to the power r. Note that to find out a general term r plus 1th term, suffix of c must be 1 less than the number of term. Suffix should be r, not r plus 1. Find out 4th term of the expansion of x plus 2y whole to the power 7. 4th term is 7c3 x to the power 7 minus 3 into 2y whole to the power cube. 280 x to the power 4 dot y cube. Example 20. Find out 7th term in the expansion of 3a minus 2b whole to the power 8. A 7th term is minus 1 whole to the power 6 dot 8c6 3a whole to the power 8 minus 6 2b whole to the power 6 is equal to 16,128 a square b to the power 6. Example 21. Find out general term and 7th term of x minus 2 minus 2y whole to the power 6. Solution r plus 1 term is the general term. Therefore, general term is minus 1 to the power r dot 6 cr dot x divided by 2 whole to the power 6 minus r dot 2y whole to the power r. There are only 7 terms in the expansion. 7th term, the last term is minus 1 to the power 6 dot 2y to the power 6 is equal to 64 y to the power 6. Example 22, expand 3x minus y divided by